Welcome to the channel, guys. In this video we'll be discussing the conditions for aromaticity, antiaromaticity and non-aromaticity. Now, why do we need to classify compounds, organic compounds, into these three types? It's because these three types, these particular properties of organic compounds assign those compounds spatial features or spatial properties. Now, what do I mean by that? Let me show you an example. For example, if I take benzene, just a moment. Okay, so for example, if I take benzene, it is a cyclic alkene, right? And if I take this alkene, that is acyclic alkene, with same number of double bonds and same number of carbons, what we see is that this benzene, it shows electrophilic substitution reactions. But this compound, it shows electrophilic addition reactions. Now, why does this shift in property happens? Why does this occur? It is because this compound, benzene, it's aromatic. Now this aromaticity, it has assigned this benzene an irregular shift from the usual properties of alkenes. In the same way, if we see this compound, this is benzene, it has a resonance, it is resonance stabilized. But if we see this compound, sorry about that, if we see this compound, it's also resonance stabilized. But this compound, it's highly unstable, while as this, it is stable. Why? Because this one is anti-aromatic and this one is aromatic. So these these properties of these compounds, they assign them different behaviors as a result of which we need to properly understand what are these properties, how can we determine if a compound is either aromatic, anti-aromatic, or any of the above. Right now, let's go through the rules that determines a compound's behavior based on its aromatic or anti-aromatic or non-aromatic character. Right now, let's first see the rules that can be applied in order to say if a compound is aromatic or not. So rules for aromaticity. Fine. Now the rules for aromaticity, they include, the first one is that it should be cyclic. The compound should be cyclic. If it is not cyclic, it's not aromatic. The second rule is that it should be planar. It should be planar. And what do I mean by that? By that I mean to say that it has no sp3 carbon. Right? The third thing that should be mentioned here is that the compound, it should show conjugation. Conjugation should be present. Let me write it down this way. Conjugation should be present. Fine. And the fourth condition, that is the most important condition, that it should follow Huckel's rules. Followed, right? Now these are the rules for aromaticity. Now let's also write down the rules for anti-aromaticity. The anti-aromaticity, let me say you, the rules are the same as for aromaticity, but there's only one difference. Let me just write that down here. All right, these are the rules for anti-aromaticity. Fine, these are the rules, but there's only one difference, that this Huckel's rules, instead of this, there is 4n pi electrons. I will be elaborating the rules. First of all, let me write them down, right? Electrons. Now, what about non-aromatic compounds? Let's also write them down as well. Non-aromatic, right? What about them? What are the rules to classify a compound as non-aromatic? Now they are also almost the same thing, but there is there is free will for them. They can be cyclic, they can be acyclic, they can be can be planar. Let me write it down here. They can be planar, or they can be non-planar. Means they can have sp3 carbon, right? sp3 carbon, right? What about conjugation? Conjugation can be present or cannot be present. So they do not follow any sort of rule about the pi electrons, neither Huckel's rules nor this 4n plus pi electron rule. These three are enough to classify as a compound as non-aromatic. Fine. Now let's take some examples in order to understand these rules, so that we can apply them and see how we proceed with these rules. Let's first take some compounds. Let me draw some compounds here. The first compound that I am taking is this one. The second compound that I am taking is this one. The third compound that I am taking is this one. Fine. The fourth I am taking is this one. Sorry. Is this one. The fifth that I am taking is this one. The sixth I am taking is this one. Now let's apply these rules on these compounds and see what are they. Let's take this molecule first. Let's apply the first rule. Is it cyclic? Yes, it is cyclic. Let's check check for aromaticity in this compound. Let's check if it is aromatic or not. So we'll be applying this rule. Is it cyclic? Yes, it is cyclic. It should be planar. Is it planar? That is, no sp3 carbon is present. Is it planar? You all know this is sp3 carbon, sp3 hybridized carbon, and sp3 hybridized carbons are tetrahedral. That is, they have two of their bonds out of the plane, right? So this one is also out of plane, and also they all are sp3 carbons, means they are not it's not a planar molecule, right? So if it is not planar, then it fails in this condition, that is, it's not aromatic. What about anti-aromatic? In the same way, it is cyclic. Yes, it should not have, it should be planar, that is, no sp3 carbon, but we saw that it has sp3 carbons, so it is neither aromatic nor it is anti-aromatic. What it is non-aromatic. Fine. Non-aromatic, because in non-aromatic it can have sp3 carbon or it cannot have sp3 carbon. All right, it has sp3 carbon, so it is non-aromatic. Fine. Hope you understand this one. So let's take another example. Let me erase these first. Let's take one more example. This one. What about this molecule? It has cyclic structure. It also has conjugation, right? But let's not go to conjugation first. Let's apply the rule number 2 first. Does it have sp3 carbons? Yes, it has. This one is sp3 carbon. Also this one is sp3. Though this one is sp2 and this one is sp2. These four, they are sp2 actually. And they are all planar. They will all be lying in the same plane. But what about these two? They are not there as sp2. They are sp3. Since they are sp3, so it will not be again aromatic. If it is not aromatic, let's check for antiaromaticity. Again, the same criteria fails them in this category as well. So they go to this non-aromatic. This compound is again non-aromatic, right? Let me erase these things over here not to avoid jumbling. So let me write it down now. It is non-aromatic again. Non-aromatic. Fine. Now, what about this molecule? In this molecule, if you see, we have cyclic structure. Yes, we have cyclic structure. Let's check for aromaticity. It should be planar. Is it planar? Yes, it is planar. it has no sp3 carbon, it is sp2, and all the carbons are sp2 in it, sp2. Fine. What about its, you know, this what about its conjugation? Is conjugation present? Double bond, single bond, double bond. It is a conjugation. What about this thing? This is also conjugation. Lone pair, single bond, double bond. What about this thing? Triple bond, single bond, double bond. These are all conjugated systems, and you might be knowing about that. So conjugation, it's not a topic of this video, but I showed you some conjugated systems. There are many, about 15 or 10 or 15 conjugated systems are there. So here you can see this is double bond, this is single bond, this is double bond, single bond, double bond, single bond, right? It is conjugation, alternate single and double bonds. So this is again what we call as present. This rule is followed. What about now Huckel's rules? Let me say you Huckel's rules. What do they say? They say if a compound follows these three rules, it should be known that these three rules are mandatory for a molecule to follow Huckel's rules. It should first follow these three rules. Then if it is following these three rules, then if it has 4n plus pi electron, plus 2 pi electrons, sorry, plus 2 pi electrons, right, then it is aromatic. What is 4n plus 2 pi? For example, if 1n is equal to 0, then this number of pi electrons, it comes out to be 2. If n is 1, it comes out to be 6. If n is 2, it comes out to be 10. If n is 3, it comes out to be 14. Fine. Let's check out that. 1, 2, 3, 4, 5, and 6. It has 6 electrons. Does it lie in this series? Yes, it lies. So what it is? It is aromatic. Right? Fine. What about this compound? In this compound as well, let me show you. Let's erase these things here. 4n plus 2 pi electrons, you might be knowing that now. So let's check for this compound now. In this compound, you might be seeing it is cyclic. Yes, it is cyclic. It should be planar. It is planar because every carbon in it is sp2. Fine, sp2. And it should be having conjugation, double bond, single bond, double bond, single bond, alternate double and single bonds. It is having conjugation, right? Just a moment. I'm sorry about that. Yes, so it is having conjugation. What about Huckel's rules? Does it follow Huckel's rules? I'm sorry about it. Yes. Does it follow Huckel's rules? No, it doesn't follow Huckel's rules. Why? Because it has, let me take the pen. All right. So because it has it has 1, 2, 3, and 4 pi electrons. 4 pi electrons, right? So it is not following Huckel's rules because it doesn't fall in this series. This 4 doesn't fall in this series. Now let's check for antiaromaticity. As I told you, for antiaromaticity, the first three rules are same as for that of aromaticity. But the last rule that varies. What is that? It should have 4n electrons. It can have 0, but practically 0 is never possible, because if there is conjugation, then there will be pi electrons. So 0 will not be practically there, but it should have 4n. If n is equal to 0, then 0. Then if n is equal to 1, then 4. Simply multiples of 4. 4, 8, 12, and 16, right? If it has this much of electrons and so on, if this has this much of electrons, then it is antiaromatic. Now we saw it is cyclic. It should be planar. It is planar. It has no sp3 carbon. There is conjugation, but it has 4n pi electrons. That is, it has 4 electrons, which is this number in the series given. So it is antiaromatic, right? I hope you understand that. It is antiaromatic. Before this molecule, let's take this one. Is it aromatic? Let's check for aromaticity. It is cyclic. It should be cyclic, but it is not. It is acyclic. In the same way, aromaticity, no, it's not anti-aromatic. I'm sorry. In the same way, for aromaticity, anti-aromaticity, it should be cyclic, but it's not. But what it is non-aromatic, because for it can be either cyclic or acyclic. This one, it is acyclic. It is cyclic, but it is non-aromatic. Fine. So this followed this one, and this one here, it is acyclic. It is acyclic and thus non-aromatic. Fine. If any compound is acyclic, you should be classifying it as non-aromatic. Fine. Now let's go to this other molecule. Hope you are understanding these things properly. Now let's take this molecule now. In this molecule, many of the students, you will see that they will be getting confused. They will be saying it is same as benzene, but it is open structure, right? Here you can see it is 1, 2, 3, 4, 5, and 6 carbons are there as in benzene. Here 6 carbons are there as in benzene. There are 3 double bonds as in benzene. The 3 double bonds are in conjugation, right? Double bond, single bond, double bond, single bond, double bond, double bond, single bond, double bond, single bond, and double bond. Fine. And also there is a resonance going on. Resonance is going on. Why? Because this will be going here, this will be going here. Fine. And this will be going here, then again they will be coming back and forth. This shift of electrons will be taking place. But is it aromatic? For aromaticity, first rule, that is cyclic, it should be followed. All of these rules are compulsory for any molecule to be aromatic. If any molecule is following 3 rules out of the 4, it is not aromatic. It should be known. So here the first rule itself, it's failing in the first rule itself, so it is not aromatic. In the same way, for antiaromaticity, all the rules are compulsory. So if it is not following any of the rules, that is this one, so it is again, it is neither aromatic nor it is antiaromatic. So what it is simply non-aromatic. Fine. I hope you understand this. Now let's take an example. Let's take this molecule, what it is. I haven't completed it yet. Most of you might have thought it has been asked. So let me ask it. So what is this molecule? Sorry. What is this molecule? In this molecule, let's apply the rules. One is cyclic. Is it cyclic? Yes, it is. The second rule is there should be there should be no sp3 carbon. This one sp2, 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 and sp2. So there is no sp3 carbon. Fine. The second rule is followed. The third rule, conjugation. Is there conjugation? Double bond, single bond, double bond, single bond, double bond. Conjugation. Double bond, single bond, double bond, single bond, double bond, single bond. Conjugation, right? So conjugation is there. Let me erase these things. So third rule, it is followed, right? What about fourth rule? That is, what is the number of pi electrons? Let's calculate that. Here we have 1, 2, 3, 4, 5 double bonds. 5 into 2, which is equal to 10 pi electrons are present. If n is equal to 2, in Huckel's rules, we get 4 into 2 plus 2, which is equal to 10, means it is aromatic. Fine? Means it's aromatic. So that's how we explain the aromaticity and anti-aromaticity and non-aromaticity of compounds. Also, you must be remembering this thing, that this molecule, when the discovery of benzene was taking place, when the stability of benzene was being worked out, fine, this molecule was found to be showing resonance, and it was showing resonance in the same way benzene was showing. The only difference is that here it has got 2 more pi electrons, right? Also, it is one step forward of benzene, that is, this is 6-membered and this is 8-membered, right? But it was found this benzene, it is highly stable, whereas this was highly unstable, and this was later attributed to it because of its anti-aromatic nature, and this was aromatic. Fine. Also, you must be knowing anti-aromatic compounds, they are highly unstable. They usually degrade into some other compounds. Hope you understand that. Make sure to subscribe to the channel Chemistry CRUX in order to get more videos like this. Thanks for watching.